Hello everyone, I'm Dr. Buddhika Lienike. So today I'm going to talk about nuclear chemistry part 1 introduction. Let's try to understand what is the electronic structure of the atom. So you all know the middle of the atom is nucleus, a nucleus containing both protons and the neutrons. So protons and neutrons together we call nucleons. So except hydrogens, all the other elements nuclei contain these nucleons, protons and the neutrons. The electrons are orbiting surrounding the nucleus. There are 118 elements total have discovered and synthesized so far by 2024. The great majority of these nuclei are unstable. So they emit radiation due to the spontaneous disintegrations to become the stable nuclei. So due to the spontaneous disintegrations of the unstable nuclei to become stable ones, we call that process radioactivity. Another type of nuclear reaction is nuclear transmutation. So, nuclear transmutation is the bombardment of nuclei by neutrons, protons, or other nuclei. The first one, the nuclear radioactivity, is a spontaneous process, but the second one is required the bombardment of nuclei, non-spontaneous process. So, both nuclear transmutation and the radioactivity are nuclear reactions. The types of radiation emitted during radioactivity can be categorized into four main types. The three are particle behavior, the other one is radiation. So, alpha particles, beta particles, positrons, they are particles, and gamma rays. The gamma rays is type of electromagnetic radiation. Let's talk about one by one. First, alpha particles. Alpha particle symbol you can write like this. The helium, the mass number is 4. We can write the upper left corner is the mass number, A number, and the lower left is the C number, or we call atomic number. So this is one way we can write alpha particle. Or you can use the Greek letter alpha as the symbol for the alpha particle. So alpha particles consist of two protons and two neutrons. The mass number is 4 at the nucleus, and the charge of the alpha particle we consider plus 2. Another name for alpha particles is helium nucleus. We call alpha particles. So alpha particles are relatively heavy compared to the other particles and radiation. So low penetration power because of this high mass so can be stopped by a sheet of paper or the outer layer of human skin. The alpha decay occurs in heavy elements like uranium 238, radium 26, and polonium 210. The next type of particle is a beta particle. So the symbol for the beta particle is the electron with the mass number 0 and atomic number -1. So actually the beta particles are high energy electrons. So we use electron symbol for the beta particles. Or you can use the Greek letter beta as the symbol. Beta particles are high energy electrons. They have high speed electrons, beta particles, and if you use beta plus, then we call positrons. Let's talk about positrons in the next slide. So beta particle charge is -1, but mass is negligible. Mass is 0. So much lighter than the alpha particles. Greater penetration power because the lower mass means penetration power is very high than the alpha particles. They can be stopped by a few millimeters of plastic or few centimeters of wood. So beta decay occurs in elements like carbon 14. Carbon 14 we use in archaeological dating, the strontium 90 and potassium 40. The next type of particle we call positrons. The positrons are antiparticle of the beta particles. So we can use two symbols, the electrons with zero mass and +1 charge, or we can use a Greek letter beta with positive charge. The beta particle charge is +1, mass is 0. This is like a beta particle much lighter than the alpha particles. Therefore, penetration power is moderate compared to the alpha. The positrons play important role in medical imaging. PET scan. PET scan is positron emission tomography. So here the positrons are emitted by the breakdown of the radionuclide. The next type of radiation emitted by unstable nucleus is gamma rays. Gamma rays symbol is the Greek letter gamma. So gamma rays are electromagnetic radiation composed by photons. They have no charge, no mass. The gamma rays have high penetration power because of this radiation behavior, and can be reduced by the dense materials like lead or several centimeters of concrete. The gamma decay often accompanies with other types of decays. The reason is the gamma decay is no mass change or no the charge change in a nuclear reaction. Therefore, it's always accompanied with the other types of emissions, alpha, beta, or the positron emissions. So let's discuss the alpha, beta, positrons, and gamma emission nuclear equations as a part 2 of the presentation. This is the summary of radiation types and particles emitted by unstable nucleus. So first alpha, alpha is helium nuclei. There are two symbols possible, two protons and two neutrons. Then mass number is 4, charge is plus 2. The second type of particle is beta particles. Beta particles are high energy electrons, or we can use Greek letter beta. Mass is 0, charge is negative 1. The next one is positrons. Positrons are antiparticle of the beta particles. It is very similar to electrons. The only difference is the charge. Charge is plus 1, but mass is 0. The last one is gamma. Gamma rays are electromagnetic radiation, not a particle behavior. So it's no mass change, no charge change when we are writing nuclear equation. So always it is accompanied with alpha, beta, or the positron emissions. So among these four, the least penetrating power is alpha because of the mass, and the highest penetrating power is gamma rays. So let's see, next presentation I'm going to explain the balance, how to balance the nuclear equations, and third part of the presentation will explain half-life calculations in the nuclear chemistry chapter. Thank you all for watching. See you all in part 2 and part 3. So if this is helpful, please subscribe the channel and comment any specific area if you need to discuss in the future.